Alright, today all we are doing is basically finding the least common denominator. Y'all have learned this before, it's been a while. I don't know how old y'all were when you learned it, but a lot younger. So we're gonna refresh on it today. LCD, your least common denominator. Okay, it is the smallest number that can be a common denominator for a set of fractions. In other words, they're the least common multiple of the denominators. Okay. Alright, so we're gonna mix it up. Instead of just doing numbers, we're gonna get into ones with variables, okay? So if I had 2 over x plus 4 over x squared, so my two denominators are an x and an x squared, right? Well, the way to make, you can actually make x become an x squared by multiplying it by another x, right? So x squared, in this case, would be our least common denominator, because I could actually multiply this one to equal this one, right? So that's what we're gonna do. We're gonna keep x squared as our common denominator, so 4 can stay on top there. I'm gonna rewrite 2 over x to have a denominator of x squared. All that has to happen is I'm multiplying by another x. So since I did that on the bottom, I'm gonna do it to the top as well. So 2 times x becomes 2x. Now we can combine these. Since 2x and 4 are not like terms, this stays as a 2x plus 4 on top. Okay, down here I have an x on one side and a y on the other side. Okay, so when you want to figure out how you can make this one and this one be the same. Well, you can't multiply x by another x to get a y like we did up here, right? We could multiply x by x to get an x squared. It doesn't work with y, okay? So sometimes you have to multiply both sides by something to make them equal. Well, sometimes you have to multiply this side by that denominator and this side by the other denominator, okay? So we're gonna do, our LCD is actually gonna be both denominators, x and y, okay? Because what I can do is I can multiply this by a y so that this denominator is xy, and then I'll multiply this side by x so this side is xy. So I'm going to do times y. So both the top and the bottom. On bottom, x times y is xy. 3 times, this is times y gives me a 3y. Minus, now I'm going to multiply this side by an x. So times x, and now I get 1x over, we'll just put the x in front, xy. Common denominators, so now I can combine. These just stay though as a 3y minus x over x. Okay, let's look at it here. Least common denominator, okay? It's always what you've got to figure out. We can first focus on the 3 and the 4, and then we'll come back to the x's and the y's, okay? So with 3, I would have 3, 6, 9, 12. With 4, I would have 4, 8, 12, so I can stop. Okay, so I know 12 is going to be part of my least common denominator, but just making these 12s wouldn't be all I could do, or I'd have to do, because over here I have an x, here I have an x squared. So it's kind of like the example we looked at earlier. I can multiply x by another x to make it be x squared, right? Okay, which means they could both end up being an x squared. And then with the y's, I can multiply this y by another y to make it be y squared. So then the least common for the y's would be a y squared. So this is going to be my LCD. For both of them. Okay, because I can multiply on the least common denominator, the smallest amount that I have to multiply or I can make the x's and the y's, okay? So this one has an x squared, which means basically you're looking at your largest exponent, okay, or your largest for each letter. Well, I messed up this too. All right. The largest is an x squared, so they both have to be at least an x squared. Same with the y's. The largest is a y squared. So the smallest I could turn a y squared into is just a y squared, right? So in order to make 4x y squared become a 12x squared y squared, it's missing a few things. First, to make 4 become a 12, I need to multiply by 3. I'm going to dot times by 3. But then my x's also need one more x, so I'm going to multiply by 3x on both the top and the bottom. Okay. Then over here, to make 3 become a 12, it's my fourth multiple. So I have to multiply by 4. X squareds match up, but y needs one more y, so we're going to multiply by another y. Okay. So 2 times 3x is a 6x, and just to double check, 4 times 3 is 12, x times x is x squared, and then we bring down our y squared. Okay. On this side, 6 times 4 is, or times 4y would be 24y. And then 3 times 4 is 12, we bring down our x squared, and y times y would be y squared. So now we put this together, and we have a 6x plus 24y over my 12x squared y squared. That's y. And that's our final answer. Okay, I said this was my final answer for that last one we just did, but actually you can simplify this, okay? You would want to look for the GCF for all three terms, okay? They don't all have an x, and they don't all have a y, okay? You have one term here, one term, and one term, okay? They don't all have an x or a y, so now we just want to look at the numbers. We have 6, 12, and we have 24, okay? I'm going to start with the smallest number, so it's 1 times 6 or 2 times 3. So I'm going to use these numbers to see if these numbers have these as factors, right? So if they're divisible by these numbers. So I'm going to start with the largest one because I want the greatest common factor, right? So is 12 divisible by 6? Well, 2 times 6 would give us 12. So far so good. Now we're going to try 24. 4 times 6 is 24. So we have a GCF of 6, okay? Our GCF equals 6. So what we're going to do is we are going to factor 6 out from everything on the top and then factor 6 out from the bottom, okay? So let me take the top. 6x plus 24y divided by 6. 6x divided by 6 is just an x. And then 24y divided by 6 is a 4y. Right? Double check. 6 times x is 6x. 6 times 4y is 24y. So we factor the top. Now we'll do it to the bottom. So 12x squared y squared divided by 6 and GCF. 12 divided by 6 is a 2x squared y squared. Okay. The reason I did this is because now I have a 6 being multiplied on top, a 6 being multiplied on the bottom. Those cancel out, leaving this to be your final answer. X plus 4y divided by 2x squared y squared as your real final answer. All right, we're gonna go back to just finding the LCD, least common denominator for some. Okay, we want a little more practice with find least common denominator like the example we just did above, okay? So here, I don't care about the numerators, the top part of our fractions. I'm just trying to find the least common denominator. So all I'm looking at, all that matters, is just the bottom parts of these fractions, right? So let's start with the numbers. We have 4, 3, and 2. Okay, so for 4, I'll list out some multiples. Well, actually, it's better to start with your smallest one, okay? Because then as you do the bigger ones, you'll know where to stop. Actually, it really doesn't matter. We'll just stay here. 4, 8, 12, 16, 20. We can probably stop there. 3, so I have 3, 6, 9, 12. Okay, so I see one between these two. Now I've got to do 2, 2, 4, 6. I have one here, but it doesn't work for all 3. Okay, so 8, 10, 12. So 12 would be my LCD for all 3. Now I'm going to look at my variables, the A's and the B's, okay? Like I said, you're looking for the largest one. So for my A's, I have an A squared, an A to the 5th, and an A to the 4th. A to the 5th is my largest one. My LCD is going to be 12. You're looking at your largest one because you can't make your large one smaller, right? Because we're not factoring right now. We're trying to find least common denominator, which means we're multiplying, least common multiple. You can't make it smaller, so that is going to be your least common denominator, is whichever one is the biggest. And then for my B's, the biggest B is going to be your B cubed. Okay, here you're going to list out all the multiples, and you found the smallest one that they had in common. Okay. And then here, you're looking for your largest one. Okay, because I can multiply A by A cubed to make it be A5. I can multiply A to the 4th by another A to make it A to the 5th, right? Same with your B's. So the largest one is going to be your least common denominator. So get a few more like this. All right, finding my least common denominator. So I'm looking at 2 and at 3. 2, 4, 6. Well, I know 3 also has 6 as a multiple. So my LCD is going to be 6. And then we're looking at our largest for each one. So for X, the largest is an X cubed. For Y's, the largest is a Y squared. And then for Z's, you only have this one. So it's just one Z. Okay. Here is slightly different, okay? These are multiples. We're only multiplying. I'm not just going to add a number here to make it become an X plus 3. This isn't adding and subtracting. This is the least common denominator, or the least common multiple, right? So in order to have an X minus 2 on this left fraction and on the right fraction, you have to multiply this fraction, X plus 3, by an X minus 2. That's the only way to get it on the left and on the right, okay? And then if I want them to be the same, the only way to make this fraction have an X plus 3 is exactly the same, to multiply this side by an X plus 3. Okay, let's separate the two fractions. If you did it to this side, to the bottom, you'd also have to do it to the top. Same here, you'd also have to multiply the top with an X minus 2. So their least common denominator would be both of their factors, the X minus 2 and the X plus 3. It doesn't matter which one you put first, X plus 3 first, or an X minus 2 first, it doesn't matter. It means the same, because they're being multiplied. Okay, so let's look at this one. X minus 3, and then an X squared minus 9. Some of you may say, oh, so I have to multiply this side by an X minus 3 and this side by an X squared minus 9 to make them the same like we did up here. That's not their least common denominator or multiples, okay? Because if I factor this, if you notice this is difference of squares, right? If you have the difference, meaning subtraction of two numbers that are squared, it is a minus b times a plus b. So that means I can rewrite x squared minus 9. The square root of x squared is x. Square root of 9 is 3. So we would have an x minus 3 and an x plus 3. So now they do have one factor in common. This side is just missing the x plus 3. So all I'm going to do is multiply this by an x plus 3 on top and bottom. So my least common denominator is an x minus 3 times an x plus 3. Okay? And now we're going to simplify a few. All right, first example, 3 over 2x plus 1 over 6x squared y. So first thing we need to do is find our LCD, okay? So I'm going to look at the numbers 2 and 6. 6 I know is an even number, so I know 2 has 6 as a multiple. Okay, so my LCD is going to be 6. If you kept going, 12 would also be a multiple for both, but we want the least common one, the smallest one they have in common, okay? Now we're going to look at our x's, which is the largest, an x squared, and then we only have one y. So that's going to be our LCD for both, okay? So I want to rewrite it to have a 6x squared y on the bottom for both. So what do I multiply 2x by to make it a 6x squared y? Well, it needs to be 2 times, it's our third multiple, so times 3. X, to be an x squared, needs one more x, and we're missing a y, so we're going to multiply by y. And then we have to do that to the top and bottom. So 3 times 3 gives me a 9xy. And then over here, I already had a 6x squared y, okay? So I don't have to change this side at all. So it's just a plus 1. So we get 9xy plus 1 divided by 6x squared y, okay? Some of you may think, oh, 9 and 6 can simplify. That is not true because you have a 1 being added here. All 3 terms would have to have that as their GCF. And we don't have a GCF for 1, 9, and 6 other than 1. So this would be our final answer. Let's look at 2 more. So this one and then 1 more. So we're going to find our least common denominator. Okay. For 2 and 4, I already know 2 times 2 would give me 4. So their least common denominator is 4. And I have 1x, and both sides just have 1y, okay? So 4xy plus 4xy is my denominators. This one already has that exact denominator, so I don't have to change that first one. And then over here, I just need to multiply 2y by another 2. 2 times 4 to be 4. I mean 2 times 2 to be 4. And I need to multiply by an x. So I get a 1 times 2x on top is 2x. These are actually like terms, so I can add those together. 2x plus 2x gives me 4x over 4xy. Both top and bottom, I'm not adding or subtracting anything up here like I was right here. So I can cancel out these 4's and these x's. Doesn't just leave me a y, that leaves me a 1 on top over my y. Okay. All right, and then the last one, I have 2 over x minus 3 over x plus 2. Once again, we are multiplying only, okay? Okay, so I cannot just say, oh, plus 2 on the top and the bottom. That's not how that works, okay? If I want this side to have an x plus 2 as a factor, then I have to multiply this side by an x plus 2. Same thing here. If I want this side to have just an x, then I need to multiply it by just an x. So your least common denominator would be x times x plus 2. You had to multiply this denominator by this side and then this denominator by this side. So I'd also multiply the top by an x plus 2 and also multiply the top by an x. Okay. So I have an x and an x plus 2 as my LCD for both fractions. Okay. So up here, I'm going to go ahead and multiply it out. 2 times x is 2x, and 2 times 2 would be 4, minus 3x. Okay, so now I want to combine like terms if I have them. So a 2x minus a 3x would give me a negative x, and then I just have a positive 4 over x times x plus 2. And you're done. If you wanted, you can multiply out the denominator. So x times x would be an x squared, and x times 2 would be a 2x. This is already in factored form, and you don't have any factors that would cancel on top and bottom, so you would leave it like this.